Hey guys, welcome to the second video on the single machine total tardiness problem with Python and Pyomo. On the previous video we described the problem. On this one we're going to describe first what is Pyomo, and then we're going to jump into Colab to make all the input data and start with the benchmark for heuristics and start modeling the problem. So first of all, what is Pyomo? Well, Pyomo is a Python-based open-source optimization modeling language with a diverse set of optimization capabilities. So if you want to have more information about the documentation and some examples, you can go to pyomo.org and it's going to be all there. But as a summary, what is Pyomo? Well, when you are trying to solve a problem via optimization, you have at least 5 steps, and these 5 steps are summarized here on the left side. First, you have to go through the problem understanding, and most likely that means interviewing a lot of people that deals with this problem. Then the translation of the problem into a mathematical model. That's what we did on the previous video. But then we have to go and translate that into into something that it's understandable by the computer, and that means using a framework. Okay, so a framework will allow me to build the model in my computer, and then we solve the problem by using a solver, and a solver is just a collection of very clever advanced algorithms that allows me to find the optimal solution of my problem. Okay, and once we're running through these 4 steps, then we obtain the results, and then we go into interpretation and feasibility, because sometimes we can have an optimal solution of a problem, but perhaps reality doesn't allow us to implement it. Okay, but that's in essence. So Pyomo, it's a framework that allows me to call multiple solvers, solvers like Gurobi, Cplex, and many others. In fact, with Pyomo, we can call all of these solvers here. We can call Gurobi, Cplex, CBC, GLPK. Okay, please note that some solvers are commercially available. That means if you want to use all their full capabilities, you're gonna have to pay, but most likely they also offer a free version. Okay, so Gurobi offers a free version. That's the one that we're going to use, and you can create up to 1,000 variables, and I think it's 2,000 constraints. Okay, if your problem goes beyond that, then it's not going to be suitable anymore. Okay, but in any case, in the code that we are going to use, we're going to have the option to use GLPK and CBC if that is what you need. Okay, so now let's go ahead and jump into Google Colab to start with the problem modeling. Alright, so here we are in Google Colab, and let's start by, first of all, installing and importing the libraries that we are going to require. Okay, so Pyomo and the solvers that we're going to use are not by default installed in Google Colab. They are not like, for example, Pandas or NumPy. We just need to import them and start using them. For these ones, we're going to have to install them. But that's easily done in Google Colab, because we can call shell commands of Unix by using the exclamation symbol. So we can call, for example, pip install -q, because I want to have low verbose Pyomo, and that will install Pyomo. We can also call pip install Gurobi Py, and that will install Gurobi Py. And let's also go ahead and install GLPK and CBC, and these ones are a little bit different. Nonetheless, please know that all the code in this video is going to be accessible in my GitHub repository, and the link is in the description down below. Okay, install -y -qq glpk .utils, and this will install glpk. And let's do something similar with cbc apt get install. Okay, so here we are installing Pyomo, it's our framework, and here we are installing 3 solvers. Normally, you don't need to install 3 solvers, you just have one that you're going to use and you install it. But here I am letting you guys choose the one that you like. Okay, so let's go ahead, let's run this, and now we're going to see how our machine in Google Colab is going to start installing these libraries. Okay, so we're getting the installation. Let's wait until it's finished. So all the solvers and libraries were installed. Now let's go ahead and proceed to import them. Okay, so import, we're going to start using the classical ones. So import numpy as mp, import pandas as pd. Let's also import matplotlib for plotting, plt. Okay, let's go ahead and import Pyomo environment as bio. Let's import solver factory module of Pyomo. That's the one that is going to allow us to call the solver. Okay, and let's import some other auxiliary libraries. In this case, we're gonna use one super useful library, itertools, and from this library we're going to import two functions, product and combinations. Alright, so these are all the libraries that we're going to need, so let's proceed to import them, and everything was imported correctly, and here we have it. So now let's input the data. So we're going to input the data that we had in the video game of the hotels. So we have here each one of the hotels, with each one of the names. We have the duration and the due date. So let's put that into our Python. So we're going to create three different lists. One that we're going to call jobs keys, and this is going to contain what? Well, it's going to contain a list of what? Well, all the letters from A up to J, so A, B, C, D, E. Okay, so that's going to create the list of the different letters. Then we're going to have the durations, and in this case it's 9, 7, 8. And let's also proceed to create the due dates. Okay, so here we have, for example, 32. Okay, so I have all the due dates, the durations, the job keys. So let's go ahead and create this list. They are now available to me, but I would like to have them in a condensed data structure. So let's put all of these inside a dictionary. So we're going to create a dictionary. It's going to call data. First is going to be completely empty. Okay, and we're going to look for I. Yes, in range of the length of all my job keys. Okay, so we're going to loop through all of the different activities, and what we're going to do, we're going to populate this data dictionary. So each one of the entries of the dictionary is going to be equal to, well, the corresponding job key. Okay, so it's going to be first A, then B, then C. And what is going to contain? Well, it's going to contain an inner dictionary on which I'm going to have the duration, and the duration is going to be equal to what? Well, durations.I, the corresponding duration of that activity. I'm also going to have an additional key that I'm going to call due, and that's going to contain the due date, which is going to be now the list due dates.I. Okay, so everything is good. Let's run this, and now let's explore what data looks like. Okay, so if I run and just call data, there we have it. We have a dictionary. On the outer keys we have the different job names, and inside for each one of the jobs we have the duration and its due date. Okay, perfect. So we have the data. So now we need to create and this is going to be useful for our binary variables based on the previous video formulation. Remember, we need to create a binary variable for each combination that we can have for each pair combination of the different keys in our problem. So we're going to create this, and that's where itertools is going to come handy. So we're going to create a list that we're going to call prod, and we're going to call the combinations function from itertools, And what we want to create is combinations of all my job keys, okay? But we want to have pair combinations, so that means only 2 items combinations. Good. And this combinations function from itertools is actually a generator, so if I want to have all of the combination, I have to transform this into a list. So I just need to pass this to the list function from Python, and it's going to generate this. Okay, so let's run this. Great, no errors. And now let's explore just what we got from itertools. Okay, perfect. So here you can see that we have all of the combinations that the unique combinations. So we have AB, AC, AD, and so on. And if you look closely, B is starting directly with C because the combination BA is already included here, and BB it's irrelevant. So as you can see, this function from itertools allow us to get these combinations. Okay, good. Now, the next step that we're going to include in this video is establishing a benchmark. It's important to know, like, okay, what is our starting point and how much we're able to optimize the schedule via the mathematical programming model. So we're going to create a naive schedule, and this naive schedule is going to use a very simple heuristic, which is just first come, first serve. That means we're going to organize these activities first with A, then with B, then with C, because A has a lower index than B, and so on. Okay, so let's create this. Let's store this schedule in a dictionary. Okay, schedule is going to be equal to an empty dictionary. Let's create it like this first. Yep, so it's going to be entered. We're going to start with we're going to create a variable that initially is going to be set up to 0, and this variable start is going to be changing for each one of the start dates of the different activities that I have. So for activity in my data, so that's going to look through all the keys, or that means all of the job activities that are included in data. That means A, B, C, and so on. What are we going to do? Well, we're going to create an inner schedule. Okay, and this inner schedule initially is going to be completely empty, and we're going to populate it with what? Well, initially we want to calculate the start, so we're going to establish a key called the start, and this is going to be equal to the start. Okay, perfect. Then we are also going to create the finish. So each activity is going to have a start and it's going to have a finish. So the finish of the activity is going to be equal to what? Well, it's going to be equal to the start, okay, plus the duration of the activity. And I can access easily the duration because I have my data dictionary. So I just need to pass what? Well, the key, which is the current looping variable activity, and what I want is the duration. Okay, perfect. I have that. I'm populating my data, and the only thing that I need to do at this point is to update that my start variable that currently is starting at 0 is going to be equal to what? Well, it's going to be equal to this information that I just created. Okay, so now if this starts at 0 with activity A, then when it goes to B, the start is going to be equal to the finish of activity A, and so on. So let's run this, and now let's explore what we have in the naive schedule. Yes, and I just missed this step. Once we update, we need to include this inner schedule into my outer dictionary. Equal to this star schedule. Yes. Okay, so sorry, let's rerun this again and let's explore what we got. And as you can see, activity A starts at 0, finishes at 9, the next one starts at 9, finishing at 6, so on, up until we finish at 99 days. Okay, perfect. So we have this schedule. So now let's measure how many penalty days we're going to have with this schedule. Okay, and this is something that it can be easily done now that we have this schedule. So let's start with a variable that we're going to call total penalty. It's going to be equal to 0, and let's loop through for each activity in my schedule. Okay, so we're looping through this, and if my current finish date for that given activity, and for this we're gonna call finish, okay, if the current finish activity in my schedule is bigger than the current due date of the same activity, okay, remember that we have this information in the data. If this happens, that means that we have a penalty. So total penalty is going to be increased. So plus equal, to say that it's going to be equal to itself plus the penalty. And the penalty is going to be equal to what? Well, the finish minus the due date. That's the amount of penalty days. Okay, that's the amount of extra days. Okay, so we're going to make this loop. And at the end, I just want to finish with a print statement to know how many different days of penalty I have accumulated. So I'm going to print, well, total number of penalty days equal to, and we're gonna use an f strings, and we're gonna put the variable total penalty. Okay, so I run this, and there you have it. We have 259 days, and that's gonna be our benchmark. Okay. In the next video, we're going to start with the mathematical programming formulation, and now we're going to call Pyomo and Gurobi to solve this problem up to optimality. Thank you, and I will see you in the next video.